Till now, we saw many Linux commands for different use cases, like displaying the contents of a directory, creating users, and assigning them to groups, etc. And in Linux, every command can have an input and output. And there is a very important concept also in Linux, which allows the output of one command to be the input of another command. So basically you can chain the execution of multiple commands on a command line interface, for example, and basically use the result of command execution of one command as input for another command. So the concept is that the output of one program can become the input of another program. And let's see with examples what I mean. For example, let's say we have a file like syslog that we want to display. And that is in var, which is the directory where many log files, for example, or caches are stored. Then we have a log directory there, which has a system or syslog file. So if I print the contents of the syslog file, you will see that there are lots and lots of log entries in this file because it basically collects and logs every single thing that you do on the system, opening programs, creating folders and files, etc. So you'll have to basically scroll in the terminal to see the start of the file. Now, if we want to see the contents in the command line interface in a more convenient and user-friendly way, what we can do is we can take the output of that command, so basically the file contents that the concatenate command gives us, and we can pass that as input to a program that is able to display large content page by page. And that program is called less. And the syntax for passing the output to the next command as an input is a pipe character, which looks like this. And depending on your keyboard layout and language that you have, this will be a different key combination. And then the program that we're passing the input to, right? The name of that program. And the concept of passing the output of one command to the next one is actually called piping. So we're piping the output of concatenate command to less, which again, as I said, less is a program that displays large pieces of information, of text files in more user-friendly manner like this. So we can read it page by page. So this is the beginning, the start of the file contents, and this is one page, and with space character, you can jump to the next page like this, and all the way to the end. And when you reach the end, you can just type in Q, and this will quit the program. So as you saw, we don't have the output of the concatenate program in the terminal itself, like we did here. So here it basically just printed everything in the command line interface itself, but with this line, it didn't print anything to the command line. Why? Because again, we redirected that printing or that result, the contents of that file, to another program that doesn't print the output to a command line interface, but it rather just lets you read it in this interactive mode. So that's mainly the concept of piping. And now let's actually see a couple of more use cases where you will see that it's actually very useful in many situations. So let's clear this up. And now let's actually print out the contents of /user/bin folder. And as you see, there are lots of different programs and command binaries in that folder, which get all printed right here. Again, not very convenient to basically be scrolling up and down to see the first entries of the command. Again, the same way we can pipe the output, which is again display of all these file names basically, and pass that as input to program less. And this will give us page by page view of all those directory contents basically. So we see it starts with A, so this is the first page, and then we have the next one, and basically using the space you can jump to the next page. If you want to move to the previous page, you could just hit the key B, and this will basically move you back, and so on. So there are actually some other sub commands of less that you can use here to navigate this view, instead of just having the static view printed out in the command line that you just have to scroll up and down to view it. And again, if I hit Q here, it will just quit the program. So much more convenient way to consume information which has basically multiple pages of display. Another very useful use case where you could use less program to basically see the output in a more manageable way is if you want to print out the history of your commands, right? If you're executing lots of commands on your operating system, you're gonna have lots of commands, right? We've been working on this operating system for just a couple of days and we already have a couple of hundred commands here. So again, if you don't want to have this history all printed out here, in the terminal window, we can do the same. We can do history pipe whatever history command gives us to program less so that it can display it better. Again, you see the very first command that we executed, which was this one right here. And then again, we can navigate back and forth using space for next page and B for previous page, and Q to quit. So these are some of the useful use cases for using piping, and specifically piping loads of output into a less program. But that's just one example. We can pipe the output of commands into any other program. For example, let's take history command again, and let's say we want to filter all the commands that have sudo in it. So basically we want to see all the commands that we executed using sudo as a super user. And how do we do that? History pipe again, and there is another program that is able to filter whatever output you give as input, and that is called grep. And this program takes the filter string as an input, in addition to the contents that it should filter, right? So it has the contents that it should look for a specific pattern and filter out the results. So we can do grep sudo. So basically look for any commands that history provides as an output that has sudo word in it. And if I execute, you see that grep, first of all, outputs the commands also in the command line interface. So we see that here. And first of all, we see that the word that we are searching for is highlighted in color, which is very nice display. So we can see it right away. Plus we have a list of all the commands that we executed using sudo. So it's a very nice traceability in case we want that history basically of all the sudo commands. And the filter pattern here, the string that we are passing or giving grep program to search for, can be anything that you want here. This could be a part of an actual word. It could be at the beginning of the line, at the end, it doesn't really matter. We can also search for multiple words or basically sentences or phrases using this grep command. So for example, we want to see all the sudo commands that we executed for changing file permissions, right? So sudo change mode, for example. However, in this case, we have to basically tell grep program explicitly that this is a phrase that we're looking for, and we have to enclose it into double quotes. So if we just have one word, not space separated, then we can do it without the quotes. Otherwise, we have to enclose the sentence or phrase in quotes. And again, execute it, and now we see the sudo change mode commands. As I said, any command can take an input from the previous command's output. And that means we can pass in the output of this command also to the next command. For example, let's clear this up. And let's see that this grep, for example, gives us still a ton of output, right? Let's say it gives us hundreds of entries because we have executed a lot of commands using sudo. So we want to see that also in a digestible and more user-friendly way. So we can actually pipe that also to another program like less. So now what will happen is history will basically give us all the history entries. It will then give that output to the grep program, which will filter the total history outputs, and that will then give its output or pass that as a parameter to the next program. So now if I execute this, you see the sudo entries that are displayed by the less program. And again, you can navigate to the next page, to the previous page, etc. And you can have this endless chain of commands basically using this piping concept. And the grep command can actually be used to filter certain strings in any type of content. This could be file contents, this could be a list of commands, or a list of files and folders itself. So to see another example, let's say we want to basically filter all the files inside this user/bin to look for a specific program or application, because if I click on the tab completion here, it will show me that there are 1,386 entries in this folder. So obviously we don't want to display all of them, right? So instead we can grep for a specific program like Java, for example, and this will show us whether there is a program Java in this bin directory. We can do the same for Python, which, as you see, displays that there are multiple Python files here. So the grep program can be used for finding whether there is a certain file or program or whatever in a directory. And we can also use it to find specific phrases or texts in a file content. So for example, in our Java project, we have the config YAML file that has some YAML contents. And let's say if this was a much larger YAML file with lots of lines of code, we could actually grep a specific value. Like for example, we can see all the places where ports are defined using ports string as a filter, or using a port number as a filter, like this. So these are some of the use cases where the concept of piping, or basically passing the output of one command to the next command as input, can be very useful. Another similar concept in Linux that is also very helpful in many cases is something called a redirection. So basically we redirect the result of a command execution into a file, for example. Again, let's see a specific use case. Previously, we saw that we filtered all the history entries for sudo commands, like this. Now, let's say we want to save that output into a file because, I don't know, maybe we want to save it for later as a history, we want to share it with someone in our team, whatever. So basically we want to have all this in a file. we can do that actually very easily by redirecting the result of this program's execution into a file using this greater than sign, which also kind of looks like an arrow with a direction, which makes sense because we're basically putting all or funneling the output of this command here into a file. And we can call this file whatever we want. I'm going to call this sudo commands.txt or .ch, it doesn't really matter, and execute. And now if I do ls, here is my sudo commands.txt file, which has the same contents as the output of these two commands. And now we have a shareable and portable file. Now let's say we decided, you know what, we also want to add some other commands in the sudo commands.txt file, in addition to what we already have there. For example, this could be all the remove commands that we executed on the system. We want them also in this commands file, in addition to what we have in the sudo commands file, but we want that as a separate file. So what we can do is we can actually copy the contents, whatever is in here, into a new file, also using the redirect of one command's output into another. So let's say concatenating the contents of this file and then redirecting that into another file. And let's say these are sudo and remove commands. That's what we're going to call this. Execute. And now if we print the contents, you see that we have exactly the same contents here. And as I said, we want to add all the commands to this file that basically removed something on the system. So if I execute this, these are the results, and we can also redirect all of that into sudo remove commands. However, note here that if I use this syntax, then everything that is in the existing content here will be overwritten. So these lines will basically overwrite whatever is inside here. If I want to append new lines or new content to the existing one, then I have to use a syntax with double greater than signs. Again, if I execute and display or print the contents, there you go, we have the sudo commands that we had previously, plus the remove commands were added in addition. Now, a very useful use case where piping and redirecting the outputs of commands can be used is, for example, if you are collecting logs of a program that is maybe printing to the command line, the console basically. So you can grab all these logs, you can filter them, and you can save them into a file, and you can either back them up or share with someone for troubleshooting, etc. So these are some of the use cases of using piping and redirecting concepts in Linux to basically combine multiple command executions and do something useful with it. So you run one command or one program and then pipe or redirect the output from that command into another and then another and so on. And as I mentioned at the very beginning, each command in Linux can have an input and output. And this input and output actually have formal or official terms in Linux called standard input or std in and standard output, std out. So with these terms, we're talking about piping or redirecting the standard output from one command to the standard input of another command. However, if the command results in an error, for example, if we are trying to display a file that doesn't exist, then it will display an error message through standard error stream, right? So we have the input stream, we have the output stream for successful outputs, and then we have the error stream for the error outputs, like this. So again, the concepts are very similar. However, if you see these terms, you will know what they're talking about. And one final thing that I want to mention here is that you can actually also execute commands independent from each other, not sharing output and input streams, just one by one on one line. And you can do that by separating them using semicolons. A good example of that would be, let's say we have a clear command, and after that we want to maybe execute a sleep command, which just waits for a couple of seconds and then execute another command like echo that basically just prints out to the console whatever we pass as an input, like this sentence right here. And if I execute this, again, these don't share any output or input. These are just independently executed commands that will be executed one after another in this order. You see, clear was executed, then 1 second was passed, and then we saw the echo execution. And this could also be a useful thing to know if you're writing maybe one line where you want multiple commands to be executed one by one. So in this lecture, we learned about very important concepts in Linux, which are piping and redirecting, and a couple of very useful Linux commands.